Okay, hi again everybody. Live again from my living room. Here we're going to talk about drawing scatter plots and best fitting lines. Okay. We need to first of all define what in the world I mean by a scatter plot. Okay. So what we're going to do is we're going to talk about how to draw a scatter plot. We're going to explain the meaning of something called the correlation coefficient. And we're going to learn how to draw a best fit line. Okay, first of all, what is a scatter plot? A scatter plot is a graph of ordered pairs of data where each pair denotes an individual. Now, that might sound a little bit strange at first. Let me give you an example here. This is an ordered pair, the number 0, 1, a point, right? Or maybe -2, 5. Those are ordered pairs, 1 pair, 2 pair. And what we're saying here is that for a scatter plot, this is an individual, and this is an individual. Now, when I say individual, we're taking that a little bit with a broader term than just a person. It could be any kind of object. But the point is that when I look at 0, 1, this 0 and this 1 go together. They describe the same thing, right? This -2 and this 5 go together. They describe the same thing. That's what I mean by each pair denotes an individual. All right, so let's look at a few examples. One example would be height and weight. So perhaps this is an ordered pair, 72 inches and 150 pounds. Okay, this is describing perhaps a person. That ordered pair describes one person. This ordered pair perhaps describes another person. Okay, so all I'm saying is that the first is height, the second is weight, first is height, second is weight, and this one describes a particular person, and this one describes a particular person. It's not as if 68 somehow goes with 150 in this case. Okay. Another, you could pair age and IQ. I'm not saying that they would necessarily go together well, but absolutely we could take a person and take their age, record that as the first number, and their IQ and record that as their second number. Okay. You could do income and number of children. Again, there's no guarantee that these are good ways to relate things, but for an individual, I could figure out how much money do they make a year. That could be the X value, and the Y value could be the number of children they have. Okay, those are all things that we can do. So, what do we do with things now? Okay, we simply graph them on an XY plane. So, if this is my X and Y, and this is going to be, let's say, height and weight, okay, then this dot, okay, is going to be an ordered pair. Perhaps it's the pair 72, 150. 72, 150. I know it's hard to read. Okay, that's the point right there. Okay, and we can collect all of the points on a graph. I know you guys have all seen this before. You've probably done this many times before. So this should be the easy part. This should be the review, where we start talking about plotting points on a coordinate system. Okay, where we have one axis denoting one variable and another axis denoting another variable. Okay. Now I want to talk about something you may not have talked much about before, and that's the concept of correlation. Now, the book doesn't do the best job of describing what correlation is. Here's what correlation really is. Correlation is the strength of the linear relationship between two variables. Now, that might sound like a little of nonsense. Okay, all it means is how much do the data look like they're aligned. That's all it means. Okay, so how much? If strong means they really look like they're aligned. Weak means they don't really look like much of a line. Maybe they look like a different shape. Maybe they don't like any shape when put together. Let's look at some examples here. Here are 3 examples. Okay, this one, it really pretty much looks like a line. If I try to use my line tool here and try to put a line through it, yeah, you know, it doesn't look too bad, right? Okay, how about this one? Yeah, not too bad. This one would be pretty hard to figure out what kind of line. I mean, you could put that line through it, I guess, but it's not real good. Okay, so that's an interesting point. This is strong. These are both strong correlations. And this one is weak. Now, there's one other thing we can say about correlation that's important. When we talk about correlation, we don't just talk about the strength, we talk about it as being positive or negative. Okay? And so when we talk about correlation, we not only recognize the strength, but we also recognize the direction. This is a, what kind of slope? Positive slope or a negative slope? It's a positive slope. So we always talk about correlation as being strong and having a direction. In this case, we have a strong positive correlation. This one has a strong negative correlation. And this one has a weak correlation. It might be positive, it might be negative, it's pretty hard to tell. Okay? And that's all we need to know about correlation. Now, we measure correlation in a particular way. We have this idea of the correlation coefficient. Every scatter plot is going to have a correlation coefficient. And every scatter plot's correlation coefficient, which we use the letter R to talk about correlation coefficient. Okay, so we see R is equal to, and R is going to be a number between -1 and +1. And here are the ways that it works. If the number is close to +1, the correlation is strong, and the slope of that line that we might be able to put through it is positive. Okay. You can imagine what happens here. If the number is close to -1, then again the correlation is strong, but this time the slope of the line that might go through the data is negative, so it's falling. And finally, if the number is close to 0, it's a weak relationship. It might be a weak positive relationship, it might be a weak negative relationship. In any case, it's a weak relationship. So let's look at those three graphs again. Okay, here's the first graph, and we can identify this as having, as we said, a strong positive line shape. Okay, a strong positive linear relationship. So this may have an R value that's close to maybe 0.8, pretty close to 1. Okay, and a positive number. Now this one has a similar shape. This might be closer to 0.75, but remember, this is negative. So we're going to be looking at a correlation coefficient that is negative and pretty close to 1. It's a pretty good relationship. This one, on the other hand, it's hard to tell if it's positive or negative. As a matter of fact, it's so continuous it might be close to 0. I'm going to pretend that maybe it's just barely positive. But you know what? At that point, it's just weak. All right. So let's look at a couple examples of some real data. Okay. First of all, let's take a look at this. Is this a positive relationship or a negative relationship? Positive relationship, remember, is that as the X value increases, okay, as this is about diamonds, right? As the size of the diamond increases, so does the price. That's a positive relationship. Okay. So we would call this a R is going to be positive. Does it pretty much look like a line? Yeah, it does. This might be an R of something like 0.9. Okay. Here's another set of data, and this data is kind of generic data. It doesn't really say what the data is. I don't like doing that generally, but that's what happens. And this is definitely a negative trend. It's not a terribly strong negative trend, so perhaps R is a negative number, but it's not terribly strong, maybe kind of sort of strong, okay? But it definitely is going down. That means that as the X value increases, the Y value decreases. That's a negative trend, so maybe R is negative 0.5. Here's a third one. Okay, again, this is if we measure somebody's grip strength versus their arm strength. Now you can see that it kind of makes sense. Someone with a stronger hand is probably going to have, in general, stronger arms. So it makes sense that this has a positive relationship in general. It's not terribly strong though, right? But it's definitely positive. So R is going to be positive, but it's not going to be super strong, so maybe 0.3. Okay. And again, this is very tenuous. I'm not giving you any equations to work with for this. I'm giving you a sense of what the value of R indicates about the graph. Okay. So let's look at the last topic for this section, and that is fitting a best fit line. Now, another thing to remember about this is, for now, we're just going to be talking about a generic best fit line. There are mathematical ways to do this, but for now I want us just to talk about what would make this a good or a bad best fit line. And for now, all I want us to say is, does it look like it's a pretty good fit? In this case, yeah, it does. I've drawn a pretty good line through it. We can kind of alter it a little bit, up and down, until we get a line that looks like it fits the data pretty well. What we're really looking for here is we're looking for any point that's not quite on the line, and no point's going to be perfectly on the line. Any point, or very rarely, any point that's not on the line, we want to try to take the differences. That's above the line a bit, that's quite a bit above the line, below the line a little bit, below the line, and so on. And we want to make sure that collectively all those distances are as small as we can get it, right? So if I move the line up here, all the distances from the line are very big. Same thing down here. If I alter the line like this, kind of skew it a little bit. Oh, I have to grab this one. You can see that down here it's fitting pretty well, but up here and over here it's not so good. So we're always looking for that balance where the values above the line and below the line are pretty offset. Okay, let's look at the next one, the negative one. Again, we're just using our eyeballs here. There's no mathematics that we have to really worry about. There's no computation just yet. And we're trying to use this just to get a sense of what's going on. Again, you know, we've got some of these points that are way off the line. Like this one is way off the line. This one is way off the line. But in general, collectively, all the distances from the line are probably about as small as we can get them if we make a line with this. Finally, here's the last one. Okay. And again, this is a pretty hard one to do. We can see that a line with about that slope and about that shape, that's about as good as we're going to do. I'm not saying it's a great line. It's not the perfect shape for this, but it is a line. And collectively, we're not going to do a lot better than a line that looks something like that. That's all there is to a best fit line for us right now. Okay, get into statistics, and we'll learn ways to do this more precisely. Okay, I want to leave you with one question here. And I want you to think about this before the lecture next time, or rather class next time. And here's the question. Based on what you know about the definition of correlation, okay, I'm going to draw a scatter plot here. And I want you to tell me this is a scatter plot, and I want you to tell me what do you think the correlation coefficient is? Alternately, you can just tell me, is this a strong, is it weak, and is it positive, or is it negative? Okay, that's what I want to know about this scatter plot. All right, so we'll see you next time.